Welcome back. We got task 4 for two variable statistics here. So in this one, we are really focusing on what does the letter R tell you, the correlation coefficient. I want you to think back to Unit 1. We talked about standard deviation. And standard deviation was one number that measured how tight or how far apart our data set was. Now, similarly, when we have a line of best fit, we can have either our dots, our scatter plot really tight or really far apart. And the letter R lets us describe very precisely how clustered our data sets are and also what direction they go in. And so that's our guiding question. How can we numerically describe the direction and strength of a correlation? That's what your R value tells you, both direction and strength. So opening up, thinking about, is it possible for any two numerical data sets to have a line of best fit? And is it meaningful if you have a line of best fit? Then there's a Desmos activity where you explore how can you move the dots around in a scatter plot to create different R values. So that'll be a good introduction to R value. Following up with some direct instruction on what the R value means. You can see here some definitions about what the correlation coefficient means, some example pictures of scatter plots with their correlation coefficients, talking about strong and weak, a lot more examples of scatter plots. And if you're interested, this is one formula. There's actually several different that are equivalent, but this is one formula that will calculate the R value. Finishing up class today by looking at the Unit 5 statistics project. This will be a chance for you to choose your own data set and use two variable statistics to analyze it. If you have time, there's another great Desmos that works on the line of best fit and making some estimates with it. So that's also there if you have time. And finishing up with an exit ticket where you're thinking about what you did and what sort of topic strikes your fancy. Thanks. Good luck.